Okay, today we're going to do exactly the backwards process of yesterday. So yesterday you were given an equation, and from that equation we wanted to find all the solutions. Today you're going to be given the solutions to an equation, and you want to come up with what was that original equation. Every problem is going to begin with the same kind of information here, which just kind of feels like a lot of jargon. I'll go through it and kind of tell you what it means, but then after that you can just kind of ignore it because it's going to be the same in every problem. So it says write a polynomial function. That means it should be powers of x. And it tells us that we're going to name it f. So our answer is then going to be f of x equals, and then we have to figure out what that is. Of least degree, which means that we're going to let our answers be singular answers. So yesterday we talked about how answers could be counted twice. It could be like double answers. When it says of least degree, it says don't do that. Like just let each answer stand alone and be its own thing. Okay? And then it says a leading coefficient of 1. We could take an equation and multiply the whole equation by 5, and it wouldn't change what any of the answers are. It would just make all the coefficients bigger. It says don't do that. Like just let it be 1. And then the part you have to start paying attention to is when it says and zeros of, and then it's giving us what the answers are. And it tells us the answers are 2, 1 plus I, and that's it. Okay, so it gives us answers of 2 and 1 plus I. What we're going to do to find our equation is write in parentheses x minus each of those answers. Okay, but remember that imaginaries have to come in pairs. So if they only give you one of a set, you have to bring in the other one. So knowing that 1 plus I is an answer means that 1 minus I must also be an answer. Even though they didn't tell us that, yesterday we said imaginaries always have to come in pairs. Okay? And that pair is the same stuff, but the opposite with the I, because yesterday we wrote it as like plus or minus. So we're just writing out that other piece. So we have 3 answers, which means our final equation should be what power? X to the third. Okay. So what we're going to do, and I'm going to get myself a whiteboard to have room to do this, is take those answers, which were 2, 1 plus I, and 1 minus I, and I'm going to write them in parentheses. I didn't leave myself in here. I'll have to rewrite them. I'm going to write them in parentheses as x minus each of those answers. So x minus 2, x minus 1 plus I, and I have to put a group around that because it's 2 things, and x minus 1 minus I. Okay, so we write x minus each of those answers. If there's more than one thing to that answer, then we need parentheses around that. So we'll have some stacked parentheses. Then the rest of the problem is just multiplying, but it's a lot of multiplying. So we have to be careful in multiplying that we are just being careful because there's a lot of places to make mistakes when we're multiplying this many things. I'm going to let that x minus 2 just hang out for a while and not do anything with it. I want to take care of all of this I stuff. Okay. So first thing I'm going to do is distribute the negatives through. So I'm going to have x minus 1 minus I and x minus 1 plus I. Now I'm going to take those 2 groups and multiply them together. We learned how to do this back, I think it was lesson like 6.2 or 6.3, somewhere back in the beginning of the chapter. We learned that we can think about kind of the idea of FOIL, but the actual words, first, outside, inside, last, don't work anymore. But the idea is that we're going to pass out the first thing to everything in the second group, pass out the second thing to everything in the second group, and pass out the last thing to everything in the second group. We have to be careful with negatives, that when you pass out something that's negative, that you're passing out the negative as well. So passing out the x gives me x squared minus x plus ix. Then I'm going to pass out a negative 1. Okay, so I'm going to multiply that whole second group by a negative 1. And I get negative x, then negative 1 times negative 1 is plus 1, and then negative 1 times positive I is minus I. And I kind of look, if there's something that's like it, I line it up underneath it, and if there's not, then I just write it off to the side. Then I'm going to pass out the negative I. So negative I times x makes negative ix. And I already have one of those. Negative I times negative 1 makes positive I, and I already have one of those. And negative I times positive I gives me negative I squared. Then I'm going to combine up like terms. So that x minus 2 is still hanging out. I'm going to combine up like terms. So I've got x squared minus x makes minus 2x. The ix's go away. The i's go away. What is I squared equal to? Negative 1. So negative I squared is equal to
1.
Positive 1. And I have another positive 1. So then I get plus 2. And all the imaginaries are gone, and that should happen every single time. You should have no imaginaries left in your answer. Part of that, like, gobbledygook jargon that was at the beginning of the problem said real coefficients. Okay, so that means all the i's should end up disappearing in the end. Okay, so if you end up with any i's left, something went wrong.
Wait, where did you get the second plus 1?
From the negative I squared. Because I squared is equal to negative 1, and so negative 1 makes a plus 1. All right, so all the i's are gone, which takes away a lot of the grossness. We're almost done, but we still have some parentheses, so we have to do a little bit more distributing here. I'm going to take the x and pass it out, and I'm going to take the negative 2 and pass it out. And when we're done with that, that'll be our final answer. So when I pass out the x, I get x cubed minus 2x squared plus 2x. And when I pass out the negative 2, be careful that we're passing out the negative as well, I get negative 2x squared plus 4x minus 4. And I combine up like terms to get x cubed minus 4x squared plus 6x minus 4. And our problem told us to call it f of x. And that's our answer. So yesterday, that's what we started with, was that equation. And then we graphed it and found whatever real solutions we could find. So if we would graph this, we would see a real solution of 2. And then we did the synthetic division and the quadratic formula to get the other solution. So we would have gotten solutions of 1 plus and minus I. So we're just working our way backwards today, saying if we already know the answers, how do we work our way back to the equation that got us those answers? Okay. Let's do another example. All right, so we can ignore all that stuff in the beginning, start paying attention once it tells us what the zeros are. We've got zeros of 1, negative 1, and negative 2 minus I, which means that we also have a solution of negative 2 plus I, because imaginaries always come in pairs with the same stuff but the opposite I. So then I'm going to start by writing out x minus each of these. So x minus 1, x minus negative 1 or x plus 1, x minus negative 2 minus I, and x minus negative 2 plus I. Okay, this time I have 4 groups, so what I'm going to do is kind of take them in pairs, and I'm going to tackle the first pair together, and I'm going to tackle the second pair together. Inside of that first pair, I'm going to FOIL them out or distribute them out, and I'm going to get x squared plus x minus 1 And inside the second pair, before I can start really doing a whole lot of distributing, I need to take care of distributing the negatives first. So I'm going to get x plus 2 plus I and x plus 2 minus I.
How come you did the first two and 12 those first instead of literally from like the second one to the
I'm just kind of tackling the pairs right now. So like if I were multiplying just 4 numbers together, like let's say I was doing like 2 times 3 times 4 times 5, I can only multiply 2 numbers at a time, but I can multiply any 2 of them. So basically what I'm doing is saying, let's multiply the first 2 together and get 6, and the second 2 together and get 20, and then in the end I'll multiply all that together and get my final answer. So I'm just kind of tackling multiply together the first 2 groups, and then we'll multiply together the second 2 groups, and then in the end we'll multiply all that together. Alright, so then in this first group, I can combine some like terms already and get down to x squared minus 1, because those x's in the middle are going to cancel. Then in the second group, got some big distributing to do. I'm going to pass out the x. Gives x squared plus 2x minus ix. I'm going to pass out the 2. Gives plus 2x plus 4 minus 2I. And then I'm going to pass out the I. Gives plus ix plus 2I minus I squared. Alright, so then I've got a lot of like terms to combine in the second group. So that first group's just going to kind of keep tagging along. X squared minus 1. Now in the second group, I'm going to have x squared plus 4x. The ix's drop out. The 2i's drop out. Negative I squared is really equal to what?
1.
Positive 1. So put that together with a 4, and I get plus 5. Now we have our final distributing to do here. I'm going to pass out the x squared, then pass out the negative 1. Be careful to pass out a negative. So I get x to the 4th plus 4x cubed plus 5x squared minus 1x squared minus 4x minus 5. Combine up like terms. And say that that is equal to f of x. We get 4 answers, so we would expect our final answer to be an x to the 4th answer. Okay, and again, all the imaginaries must disappear. If you have any imaginaries left, something went wrong. Questions? All right, one more example. Okay, so we can ignore most of it. At the end, we just care about what the zeros are, 2, negative 2, and 6i. Now, in the last example and in this one, we've had the opposites of the real answers too. So we had like positive 2 and negative 2, and in the last one we had opposite answers as well. That does not have to happen. Okay, so with the real numbers, we just do what they give us. Okay, whatever answers they give us, that's what we have. We don't bring in any more real answers. Okay, so the real answers will all be there. Whatever it gives you, those are the answers, even if the opposites aren't there. But for imaginaries, the opposites have to be there. So if they don't give you both of them, then you have to bring in the other one. So what's going to be the other answer with 6i? Negative 6i. So then we're going to set up our groups of x minus each answer. So x minus 2, x minus negative 2 is x plus 2, x minus 6i, and x minus negative 6i is x plus 6i. And this problem is actually a little bit cleaner because since we don't have something that's like 1 plus 6i, we don't need the extra parentheses and we don't have to distribute a negative. There's not as much stuff here since it was just a plain 6i and not like a 1 plus 6i. So that's nice. So like the last problem, since I have 4 groups, I'm going to kind of group them up and tackle the real ones together and the imaginary ones together. Last week, at one point, we talked about some shortcuts, and if you notice that the groups you're multiplying are the same stuff, but one group is plus and one group is minus, what will happen? The outsides and insides will cancel each other out. So you could do the full distributing here, but really all we have to do is the firsts and the lasts, because the outsides and insides are just going to cancel each other out. And that'll happen every time that you're multiplying the same stuff, but one's adding and one's subtracting. If you don't notice it, it's no big deal. You just do the whole FOIL multiplying, and then your outsides and insides will end up canceling. So you'll end up in the same place. It's just 2 extra multiplications. That actually happens in this second group as well. That it's exactly the same stuff, but one is added and one is subtracted. So I'm going to get x squared minus 36i squared. Multiply my first and multiply my last. Again, if you did the full thing, it's fine. Those outsides and insides will just end up becoming 0. What is minus 36i squared?
Plus 6. Negative 6i.
What's I squared? Negative 1. So negative 36, negative 1 would be
36. No.
positive 36, because we're multiplying. So it's like negative 36 times I squared, which is negative 1. So that whole thing turns into positive 36. And I squared just changes the sign of its term. So now we're going to distribute here. I have to do the full foiling here because they're not opposites anymore. So I get x to the 4th plus 36x squared minus 4x squared minus whatever 36 times 4 is. It's 144. Yeah. So then combine my like terms and I get f of x equals x to the 4th plus 32x squared minus 144.
What would the
The squareds are like, I have a couple heads ups for you on your homework. So on the homework, it's just the last 5 problems because you did the first 5 last night. But there are some that students make some common mistakes on, so I want to point something out to you. First, on number 43. On 43, you're given solutions of I and negative 3i and positive 3i. What else do we need here? A negative I. And that's all we need because the other one, the pair is already there. So if the pair is already there, you don't have to bring in another pair of them. It's just that if the pair isn't complete, we have to complete out the pair. Okay? 44. 44, students commonly misread the answers. So it tells you the answers are 3 minus I, comma, 5i. A lot of students inadvertently put a comma after the 3 and say the solutions are 3 minus I and 5i, okay? It's 3 minus I and then also 5i, okay? And then you have to bring in their opposites as well. Just be careful that you read that problem appropriately, okay?
So you add 3 plus I and negative 5i?
Exactly. Yeah, so we'll have 4 solutions on that one. 3 plus I and negative 5i will be the other ones have to go in there.
What if it's just real numbers?
If it's just real numbers, then we don't have to bring in any imaginaries. Just like yesterday, there were some problems we could graph, and we would see all of our answers, and that made it kind of an easier problem. Same thing here. If there's no imaginaries there, you don't have to introduce any. It's just all going to be real numbers, and you don't have any eyes to worry about. And that'll happen on some of your problems tonight.